right, Algebra 2 final exam review. Here we go. So number 1, linear equation. All you got to do, distributive property. So that negative goes to both of those guys. Again, distributive property, we're going to distribute that -3. There we go. From there, we're just going to combine our like terms. Get the x's on one side, doesn't matter which. I'll get the x's on the right this time. And I'll get my constants on the left. So that gives me 27 equals 11x. Divide by 11. So we get 27 over 11 equals x. All right, number 2. Notice this one's got x squared. That makes it a quadratic. There's no higher degree. 3x squared plus 2x, standard form tells us to get it equal to 0. So I'm going to say -6 equals 0. Now it's the standard form of quadratic. We go ahead, take our calculator, mode 5-3, and we type in our coefficients. 3, 2, -6. And we hit equals, we get x1 is that. -1 plus square root of 19 over 3. -1 minus square root of 19 over 3. So those are our answers. So we can write that as a single answer, -1 plus or minus square root of 19. And I believe the whole thing was over 3. Let's check again. Yep, the whole thing over 3. That's it for number 2. Number 3. Another quadratic. A ball is thrown vertically upward from the ground. Its distance in feet from the ground in t seconds is, given by this equation, s equals -16t squared plus 117t. After how many seconds will the ball hit the ground? And let's say round to the 10th. Okay. So it starts on the ground, and we want to know when it lands on the ground. So how high off the ground is the ground? 0. 0 equals -16t squared plus 117t. Another time, we're going to go to our calculator, go to mode 5-3. This time, -16, 117, 0. -16, 117, and 0. We get 117 over 16, which is about 7.3. Let me write that down. Or we get 0. So let's make sense of this answer we got. It wants to know when will it hit the ground. Well, it started on the ground at 0, right? So that's not what we're looking for. We want to know when it goes up and then comes back down. So this is our only answer, 7.3 seconds. That's an S. That didn't work. Hang on. Eraser. There we go. So 7.3 seconds. All right. Complex number. This is probably the easiest problem on the test. You type this into mode 2. So take your calculator. Mode 2. And just type it in. It's a fraction. It says 2 minus 3 I. I is right here above the 8. Don't have to hit shift or anything, just hit the I button. Over 4 plus I. Hit equals, and there you go. That's it. It simplifies it for you. 5/17. minus 14/17 I. Now, if you put I in the numerator, that's fine. If you put I in the middle, it's fine. If you put I in the denominator, I'm marking it wrong, you get 0 points. So make sure I is either in the numerator or the middle. You put it down here, it's wrong. Now we got a radical equation, so first step of solving a radical is to isolate said radical, which it already is. So I'm going to take both sides and raise them to my index, which in this case is 2, since it's a square root. Square that side. This is easy enough. 2x plus 1 equals, and then go ahead and write this out. 5 minus x squared means 5 minus x times 5 minus x. 25 minus 5x minus 5x plus x squared. Notice it is a quadratic, so let's go ahead and get it into standard form. I need it to equal 0. To do that, I'm just going to bring everything to the right side. You could bring everything to the left side, it's fine, but I'm doing it this way. Your choice. So 0 equals, I'm going to put my x squared first. Negative 5, and negative 2 makes negative 12x plus 24. All right, we got ourselves a quadratic. Let's go back to our calculator. Mode 5, 3, and we're going to type it in. 1, negative 12, and 24. Okay. And it's thinking 6 plus 2 square roots of 3, 6 minus 2 square roots of 3. So I'm going to write those down, but I'm going to do it separately. 6 plus 2 square roots of 3, 6 minus 2 square roots of 3. This one did not start out as a quadratic. It started out as a radical equation. So I got to check for extraneous roots. That's why I want to separate them in case one of them works, but the other one does not. Yes, we must test them exactly like it is. So over here I'm going to test square root 2 times 6 plus 2 square roots of 3 plus 1 equals, and then 5 minus 6 plus 2 square roots of 3. And then on the other one, we're going to do square root of 2 times 6 minus 2 square roots of 3 plus 1. And we're going to test and see if that's equal to 5 minus 6 minus 2 square roots of 3. So what I'm going to do is I'm going to find the left side of the equation on both of these first, because we'll just make our lives a lot easier if we do that in the calculator. Okay, let me change my color and go over here. So go back to mode 1. Square root. It's 2 times 6 plus 2 square roots of 3 plus 1. Make sure you get out of that radical before you hit that plus 1 right there. That gives us 4.46. Go to hundreds place. As long as they match hundreds place, probably matches all the way. 4.46. Okay. Now, we need to see if that's equal to this other side here, but let's go ahead and get this one first because it's a lot easier for you that way. Watch. Hit the left arrow key. Go back and change this to a negative. Come on. Minus 2 square roots of 3, and that gives us 2.46. So that's why we wanted to get those first. Less typing. And we need to see what this side equals. Now we're going to test this side over here. So it's 5 minus 2 plus 2 square roots of 3. Let's see what that is. Hit SD. I probably typed something in wrong. Let me see something. 6 plus 2 squared is 3, sorry. Go back and change that. And see what that is. Negative 4.46. There we go. I figured it would be the opposite sign there. That's why I knew it was wrong. Negative 4.46. Now over here, let's see if this one works. Just going to change that plus to a minus. And we get 2.46. So that one does work. So the minus works. But the plus does not. That's an extraneous root. So this one, not equal to this one, checks out. Let's see what we got next. All right, we got ourselves an inequality here. So again, just like an equation, the only difference is if we multiply or divide by a negative number, we're going to change the direction of our inequality symbol. So let's just use the distributive property. Now typically I combine like terms and solve from there, but if you notice, this is the same as that, and this is the same as that. So right away I just get x is less than 0. It's very important you know the names of these symbols. That's a less than symbol. That's less than or equal to, greater than or equal to. Make sure you know the names of your symbols. If you don't, you fail. Now it says to solve and graph. So we solved it. Let's go ahead and graph it. We'll be graphing these on a number line. One will be provided on the answer key for your test. Here's a 0. It says x is less than 0. So that means we need everything to the left of 0. But do we include 0? No line under there. We do not include 0. So we need an open circle. And then we shade. As such. Now, for our final solution, we're going to write that in interval notation. Remember, we got a negative infinity, always in parentheses, up until 0. We do not include it, so that's also having a parenthesis. So the graph and the interval notation both would be counted for your answer. If you just have this, you're going to get 1 of the 4 points. All right. Okay. Another inequality. This time, we got an absolute value inequality. So it's extremely vital that you know how to read these, because this symbol, yes, it's less than or equal to, but for our absolute value inequalities, it's a less than. So you're going to make a sandwich. And however the heck you spell sandwich, I probably misspelled it, who cares? But yeah, to do that, you're going to go negative 75 less than or equal to the inside part of our absolute values, less than or equal to 75. That's our sandwich. If this was a one of these was a great OR, you split it. And you'd set up the 2 different inequalities from that. So you'd have 42 plus 3x is less than or equal to 75. 42 plus 3x is greater than or equal to negative 75. Just on the second one you change direction. But we don't have that. We got this, so let's do it. Subtract 42 from all 3 sides of our equation. That's negative 117 less than or equal to 3x less than or equal to 33. Divide by 3. That's negative 3, and that's 27.9. Less than or equal to x less than or equal to 11. And from there, yeah, we're going to go ahead and graph it. Don't know why there's an M there, ignore it. So we got negative 39. We got 11. And if we look, we do have the lines under here, so that's less than or equal to. So that means we do include, hey, I changed my color. Where is it not changed? Less than or equal to, so we have a solid dot on both of those. And x is sandwiched between them, so we shade between them. That is our answer there. In a rotation, we're going to use a bracket. Negative 39 to 11, close our bracket. All right. Next up, we've got midpoint and length, which is distance. So for the midpoint, you find the middle of the 2 points. You add the x's and divide by 2. You add the y's and divide by 2. That's the entire midpoint formula. I'll take either fractions or decimals on this one as long as it's no terminating. So you're dividing by 2, it's going to be either a whole number or 0.5, so it's fine. So this is fine, or you could say negative 1.5 and 5.5. I prefer the fractions, but I'll also take this. Either way. Oops. Now over here we have to find the distance, the length. You could, if you remember your Pythagorean theorem, kind of imagine where these go. So if we start at 0, 0, this negative 3, 4 dot would be left and up. This 0, 7 dot would be up here. And you just kind of make a right triangle out of it. So this side up and this side right here. They intersect at a right angle. We want the distance, so we just need to use Pythagorean theorem to find that. How far apart are they here? Well, from negative 3 to 0 is 3 units. From 4 to 7 is also 3 units. So 3 squared plus 3 squared equals x squared. And then from there, that's 9 plus 9 is 18. So square root of 18, which does simplify if you type it in the calculator to 3 square roots of 2. Now, you could also just use the distance formula. You get the same result either way. X2 minus x1 squared plus y2 minus y1 squared. So if you memorize the formula, you're done. If you don't memorize the formula, draw a triangle. Get it that way. So square root x2 minus x1. So negative 3 minus 0, that's negative 3. y2 minus y1, 4 minus 7, that's negative 3. And as you can see, we got the same thing we got over here. So we will again get 3 square roots of 2 for our final answer. And I'm hoping my face isn't in the way right now. It's the same thing as it is over here. All right. Writing the equation of a line. Remember, to write the equation of a line, start with your point-slope form. Y minus y1 is equal to m times x minus x1. Anytime you need to write the equation of a line, start there. So, y and x stay y and x. We got our point here. This is x1, that's y1. It's perpendicular to this thing. So remember, perpendicular means it has a negative reciprocal slope. So if I look at just this piece right here, find the slope of that, it's going to be negative 5/2. Easiest way to do that, solve for y, and whatever the coefficient of x is your slope. I don't care about the 15, so to get the slope, I divide by 2, negative 5/2. To get the perpendicular slope, which is what we need to use here, perpendicular slope, we're going to flip it. It was negative, now it's going to be positive. Negative reciprocal. That's our m. Plug and chug now. Y minus 6 equals 2/5 x minus 6. So there's the equation of the line. It's not in standard form though. To get it in standard form, we're going to distribute, get it into the form, let's write in a different color, ax plus by equal to c. So that's our goal. Let's do it. Y minus 6 equals 2/5 x minus 12/5. Use a calculator if you need to. Right here, right now, I'm going to get rid of my fractions. Multiply both sides of my equation. Yes, I know I shouldn't multiply to an equal sign, but whatever. By our LCD, which is 5. 5y minus 30 equals 2x minus 12. We need to get it into ax plus by equals c. A has to be positive. No fractions. And our GCF has to be 1. So I have to divide through any common factors we may have, which I don't think we're going to have any because that's a 5 and that's a 2. So I'm going to bring my, actually I'm going to bring my y over because I want x to stay positive. So 2x. I need to subtract 5y. There we go. Minus 5y. So minus 5y equals. Now, I need the 12 to move, so I'm going to add 12. I need the 12 on the other side. That's going to be 18. There we go. Standard form. Done. So that's all you got to do on that one. 2x minus 5y equals 18. Again, find an equation of the line in standard form. This time we have 2 points. Always start with point-slope form. We're trying to find the equation of the line. Doesn't matter what you call x1 and y1. You can use either set of points. Makes no difference. What you do need to do, though, is your slope formula. All right, and yes, you need to remember all these formulas. All right, so we got our slope formula. Let's just plug in our points. Make sure whatever you call point 1 on the top, you call point 1 on the bottom. So if you use 6 first, you better use negative 4 on the bottom. If I were to use 12 first, then you'd have to use the 4 on the bottom. So it doesn't matter which point you start with, as long as you keep starting with it. So this could be 6, negative 4, 6, negative 4, or you could do 12, 4 first. Either way, you'll get the same result. That's negative 6 over negative 8, which is positive 3/4. That's our slope. Y minus, again, it doesn't matter which one you pick, so I'm just going to go with the one that has all positives. Positive 3/4, x minus 4. And again, you can use either point as long as you use that whole point. So 4/12 or negative 4/6. Y minus 12 equals 3/4 x minus 3. It does want it in standard form, so again, let's get rid of that denominator before we go any further. So that's going to give us 4y minus 48 equals 3x minus 12. We need x, ax plus by equals c, so again, that's already positive. I'm going to leave it there. I'm going to subtract 4y. From both sides, and I'm going to add that 12 to both sides. Equals, and that's negative 36. So again, that's standard form. Ax plus by equals c. Make sure there's no GCF, no common factors. 3 and 4, nothing in common. You can always check on your calculator if you need to. Alpha multiply 3 comma, obviously 4 is going to have a 1, but if you did something like 42, that would tell you the GCF is 3. So whatever that is what you would divide by. So if we had 42 instead of 4, we'd try and divide 3 by 3. However, in this case, we're good. That's it, standard form. Next problem. Synthetic division. So, to start with, you find out what makes this equal to 0. -1. Start there, put it inside the box. Write down all of your coefficients. 1, 1, 0, -14. That goes to 1, -1, combine like terms. Remember, we bring down the first one, multiply, that gives us -1, combine, multiply, combine, multiply, combine. All right, so this tells me if we divide that, we reduce the degree by 1, so it's going to be 1x squared. I'm not going to write the 1, but you can. Plus no x's, plus no constant, plus -14 over x plus 1. It would be perfectly fine if you wrote a minus 14 over x plus 1 here. That would be fine too. I'll take either way. Next up, we have this guy. It's already in standard form of a quadratic, so go ahead and type it into mode 5.3. It says give the vertex and the intercepts. So it wants the vertex and intercepts. Let's do it. Mode 5.3, and let me see what the problem was again. 1, it's x squared, -3, and -10. So first thing it gives us is our x-intercept, 5 and -2. Those are our x-intercepts. Let me write those down. So as ordered pairs, that would be 5, 0, and -2, 0. The next thing it gives us is also important. 3 halves, -49 fourths. That is our vertex. Now we definitely need to look at that as decimals instead of fractions. For -49 fourths, I have no idea what that is. Well, yeah, it's like 12 and a bit. So we're actually not going to be able to plot this on the graph I have, so I'll make sure the graph is big enough whenever we get there on the test. But yeah, so -12 and a quarter. Let me double check that one. Yeah, 1.5. So 1.5, 12 and a quarter, negative. So 1.5, -12.25. Give me a second. Let me go get a bigger graph. All right, we're back. So yeah, I had to go get a different graph because this wasn't going to fit on there. It says plot the intercept. So we have our two x-intercepts. We also need our y-intercept. Well, that's easy enough. We plug in 0 for x. We get -10 for y. So we plot these 3 points. 5, 0. -2, 0. 0, -10. And we also need our vertex. 1.5. So right there in the middle. -12. So that's 11, 12, and a little bit, 12 and a quarter, right there. So that's my vertex. Okay. So remember, the line of symmetry for this thing goes straight through that vertex. So if I'm 1.5 spaces over here, I'm going to go 1.5 spaces right here. This should also be a dot on my graph. 1, 2, 1, 2. So yeah, this is all lining up. So now this is what my parabola is going to look like. I'll do that in red. Forgive me, this is probably going to be a terrible graph. Yeah, and something like that. Make sure this is rounded and not pointy. If it's pointy, I'm going to take off points. So yeah, that's about it. Next. All right. Function operation. So it says g minus f of 2. Easiest way to do that, find g of 2. Negative 5 times 2 minus 1. That's negative 11. Just type it in the calculator. Oh. F of 2. That's 2 squared minus 2 times 2. 4 minus 4 is negative, 0. So we have g minus f, so negative 11 minus 0 is negative 11. That's how it is for that one. This time we're composing the functions. So we're going to plug x into g, plug g of x into f. X is already in g, so we're going to take this and shove it in there. 12, instead of x, we're going to put some big parentheses in that thing, and we're just going to put what g of x is inside of those parentheses and simplify it. 96 minus 12x plus 7, 103 minus 12x. If you got this, I'll give you 3/4 of the points. Finish it off, get the last point. Okay. All right, so it says we got a partial solution set and wants the complete solution set. Again, we got ourselves some synthetic division going on. It says x is 0. That's what we're going to use in the box. Write down our coefficients. We have no constant here, so I'm going to put a 0. 1, 0, negative 7, 0, negative 18, 0, 0. All right, so that was our first synthetic division. It reduced the power by 1. It's now x squared minus 7x minus 18. You're welcome to try and guess at what the answer is going to be with any method you want, or you can just say, hey, it's a quadratic, type it in modify 3, and be done with the dang thing. That's what I'm going to do. Oops. Let me go here. No. Yeah. Sorry. 1 second. There. Mode 5, 3, and our coefficients were, I forgot, same as the original. 1, negative 7, and negative 18. So you should get like negative 9 and 2, I think. No, positive 9 and negative 2. X equals 9, x equals negative 2. Sorry, I got my signs backwards in my head. So the complete solution set would be x equals 9, x equals negative 2, and x equals 0. Don't forget that one. They gave it to us. It's part of our solution set. You could use the fancy curly brackets and put 9, negative 2, 0. But I'll take this just fine. Okay. And let's get 16. All right, so now we got a system of 2 equations. So easy enough. Take our calculator. Mode 5, 1 this time. And we just type in our coefficients. Make sure you are in standard form. ax plus by equals c, ax plus by equals c. All of your equations need to be in standard form before you put them in the calculator. Coefficients for 1, 2, 1, negative 1.
Miss Shirley, could you report to the office, Miss Shirley?
3. And then we just hit equals. X is 1, y is negative 2. Done. The correct way to answer this would be as an ordered pair. The end. Let's note that this is not interval notation. This is a point, a single answer. X is 1, y is negative 2. This does not mean every number between 1 and negative 2. So point, not an interval. Oh no, a system of three equations. How do we do that one? Mode 5-2. So again, let's double check. Are they all in standard form? X's, Y's, Z's, constants. Okay, we're good. Mode 5-2. For -5, for 19, -1, -5, -5, 2, 1, 5, -1, -20. So we get x is -2, y is -3, and z is 3. X is -2, y is -3, z is 3. Oops. And the way to write this would be as an ordered triple. Let me just double check. -2, -3, 3. -2, -3, 3. Yeah, so the correct way to write this would be an ordered triple instead of an ordered pair. And that's it. Done. Next. All right, exponential equations. So we only have the easy ones this year. I'll get you the logs next year, don't worry. So we need to find some way to make these have the same base. So we could write them both 8 and 64 as powers of 2. Or you can just be like, oh, hey, 64 is 8 squared. That's the easier way to do it. But both ways will get you the same result. So from here, if the bases are the same, the exponents must be the same. All right, so 6y is -2. Y is, divided by 6, -1/3. Done. Next. Same base already, so just set them equal to each other. 6m equals 3m minus 8. Subtract 3m. So we get divided by 3, -8/3 is m. Also, these, they are going to work. They don't have extraneous roots, so you don't have to check them. So it's rational equations and radical equations you have to check, not exponential. All right, 216, you might not know it, but that's 6 to the 3rd power. If you don't know it, figure it out. You know you gotta have a base of 6 and you can't break a 6 down. There's nothing 2 to the 3rd power, 2 to the 2nd power, none of that is equal to 6. So, go to mode 1, try it out. 6 to the, maybe it's a 5th power, let's see. It's not 6 to the 5th power, maybe it's a 3rd power. I suggest going in order, you know. 216, it is 6 to the 3rd power. So that's how you figure it out on the calculator. 216 is 6 to the 3rd. So 3 equals 2r minus 11. 14 equals 2r. Divide 3 by 2, and 7 is equal to r. Done. That is the entirety of our final exam review. Congratulations. Study, pass, should be fine. Bye.